Sayed on Maths Online. Today we'll be dealing with the topic angle between two polar curves. Let me give the result with the help of the figure. Let us consider the initial line OL. So these are the two polar curves. Let me draw the radius vector. So for the two curves, I've drawn the tangent. I've just shown the tangent in two different colors. One is red color for one of the tangent and blue color is another tangent. Those are the two tangents drawn to two different curves. Let me consider the first curve to be equals to r is equals to f1 of theta, and the second curve to be equals to r is equals to f2 of theta. So theta is the angle between the radius vector and the initial line. So if I'm taking P as the point, then r will be the radius vector over here. With respect to the red tangent, I am taking that angle to be equals to say phi 1, and with respect to the blue tangent, if I am taking the angle to be equals to say phi 2. So those are the two angles for two different curves. Angle between two curves will be equals to phi 1 minus of phi 2. So where this phi 1 and phi 2 are the angles made with the radius vector and the respective tangents. So let me take this as modulus, because the angle should always be positive irrespective of phi 1 and phi 2 are a greater value or a smaller value. So the difference should always be positive. So that is the angle between the two polar curves, phi 1 minus of phi 2. And we already have one more relationship. Whenever you have two different angles, you can even write down. Suppose we'll try to take different cases. Suppose the first case, if this difference phi 1 minus of phi 2, that is equals to pi by 2, 90 degree. So if the difference between the two angles is pi by 2, then we say that the two tangents are perpendicular to each other, are perpendicular to each other. Or in the other way, I can say that the two curves are orthogonal to each other. Two curves, which is r is equals to f1 of theta and r is equals to f2 of theta. Those two curves are orthogonal to each other. Orthogonal to each other. So whenever phi 1 minus phi 2 is pi by 2, we can say that the two curves are orthogonal to each other, which means the two tangents are cutting each other at 90 degree. There is another relationship. Even suppose if you have tan of phi 1 into tan of phi 2, if the product between these two is minus of 1, even in that case, you can say that the two curves are orthogonal to each other. So we have two relationships where I can say that two curves are orthogonal to each other. So the first relationship is if phi 1 minus phi 2 is equals to pi by 2, or if tan phi 1 into tan phi 2 is equals to minus of 1, we say that the two curves are orthogonal to each other. So that's all I have for today. Thank you.